Okay, so this one here, we're gonna draw the graph of y equals x squared plus 1. So it's going to be this parabola here. And we're going to rotate this graph around this line y equals 5. Okay, so I'm just going to draw this a little bit better. It's going to look more like that. So we need to know the bounds of integration. So we need to know when that graph is equal to y equals 5. So we're solving that, we get -2, +2. Okay, so that's what it's going to cross. So we want this region here, which I'm going to shade. Okay, this region here is going to be rotated around that line, which is going to generate kind of like a disc shape, and we want to find the volume of that. So how do I get the volume of that? Well, I need to integrate from -2 to 2, and I want to do the radius squared times pi. Okay, and that will give me the volume. And I'm going to use slices of dx. Okay, so I'm going to use these slices here. So I need to figure out what the radius is. Well, the radius is going to be the distance from the center of the rotation to the outside edge, okay, which is that line there. So how do I get this distance between this length? I get length by subtraction. So if I start with y minus 5, so the r, I'm going to do it over here, r is equal to y minus 5 minus the height of that line, which is this length here, or x squared plus 1. Okay, so that would be the length of the radius. When we subtract two positions, this position of 5 and this position of y, okay, we're going to get the length, which in this case is the radius, is what we're looking for. So then when I want to integrate this, it looks like this. The volume is equal to pi from -2 to +2 for r squared. Okay, so I'm going to write like this, r squared dx. The r is going to be 5 minus 1, so it's going to be 4 minus x squared. So there it is. There is my integral. I can integrate this. I'm going to expand that out. It's going to be 16 minus 8x squared plus x4 dx. Plugging it in, we're going to end up with 16x minus 8x squared, 8x cubed over 3 plus x5 over 5, and we're going to integrate that from -2 to +2. Okay? So plugging that in then, plugging the the 2 into here, we're going to end up with 32 minus 64 over 3 plus 32 over 5 minus the negative, those are all odd functions, so it's going to be minus the opposite of all those pieces. Okay, so when you work that all out, well, what's that going to be? Let's see here. Put that to my calculator. 32 minus 64 over 3 plus 32 over 5. Okay, that's going to give me 256 over 15, and then I'm going to double that, so that ends up being pi times 512 over 15. Okay, so there's our volume, and this is going to be units cubed. Okay, so when we look at the next one here, washers. Okay. When we look at the next one, doing it by washers, what we're going to do is first of all, imagine the shape. So imagine this parabola. It's going to be rotated around the y-axis. So it's going to kind of give us this, cylinder with this carved out parabola. And when we take slices, we're going to slice in this case along the y-axis. So we're going to use dy. When I take slices of this, the cross-sectional area, that we're going to get are going to be what we call washers. Okay, they're going to be discs with a hole in them. Okay, these are what we call washers. Okay, so it's going to look like that. That's what the cross-sectional area is going to look like. And to get the area, we're going to take the big circle minus the small circle. Okay, that's going to give us the areas to which we can give thickness for volume. So to set this up, I need to have an outside radius. In this case, outside radius for the red circle is fixed. And I need to have an inside radius. The inside radius is going to be this length in here. Okay, now that is not a y value, that is an x value, or an x position in this case. What we can do then is, if I want to find out x, and I want to integrate along dy, I need an equation. I need to convert this y equals x squared equation into an x equals root y equation. Okay, so when I do that, this x now is going to be the same as root y, and I'm going to use this root y expression with a dy to be able to integrate it. So then it looks like it's going to end up looking like this. So the area is going to be the big R squared. Okay, so the area is equal to big R squared minus little r squared times pi. Okay, so pi r squared big circle, pi r squared minus pi r squared small circle is going to give us this cross-sectional area. And when we want to find out the volume of that, we want to know the volume from A to B, okay, of the area times dy. Okay, that's going to give us volume pieces, and we're going to sum up those volume pieces. So then we got to figure out, we're going to start at y equals 0. This is going to be y equals x squared, so that's going to be y equals 9. So we're going to integrate along there. So the volume then looks like this from 0 to 9 along the y-axis. The area is going to be pi times big R squared minus small r squared. Okay, and then that's going to be with dy. Convert those expressions into, I'm going to convert that into the radius squared. The outside radius is 3, so that becomes 3 squared minus the r squared. Well, this is going to be my r. It's going to be square root y squared times dy. This ends up, I can integrate this fairly easily. This becomes 9x. This is, 9y. This will end up being y, square root of y squared is y, so we're going to get y squared over 2 when I integrate that. That's going to be from y equals 0 to y equals 9. Plugging that in, my volume ends up being 81 minus 81 over 2 minus 0. Okay, so that's going to end up being 0 there when I plug in the 0. So I end up with, the volume ends up being 81 pi over 2 units cubed.